San Andreas Fault.
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 There hasn't been a big earthquake on the southern San Andreas Fault for a long time, and we may have found a reason why.
It goes north to south, but it does make a little turn here near Santa Barbara in what we call the transverse range.
Beneath the tranquil waves and sunlit boardwalks of America's coastline lies a world of restless energy, one that is threatening to reshape the land faster and more violently than we ever imagined. Beaches that seem eternal, seaside towns that feel untouchable, and even inland cities we think of as safe are no longer immune to unseen forces brewing deep within the earth. The latest research from the United States Geological Survey, USGS, has brought an unsettling truth to the surface. Our nation's coastlines are changing, physically deforming, on a scale and at a pace that demands our urgent attention. Armed with cutting-edge mapping, scientists are revealing nearly 500 additional faults that could, at any moment, unleash devastation. The National Seismic Hazard Model now warns of a 15% chance of a magnitude 8.0 or greater earthquake along one of America's most infamous fault zones, a number that represents a significant peril, far more alarming than mere statistics on a page. But it's not only the threat of shaking the earth that looms. Research indicates that the very ground beneath our feet, especially along the coast, is sinking and shifting, swelling the risk of catastrophic flooding. Once high and dry lands may, within a human lifetime, find themselves submerged. Plate tectonics, hidden faults, glacial rebound, and even the cumulative effects of human activities are inexorably rewriting the map of the American coast. The question haunts every scientist, policymaker, and homeowner along the water's edge. What is truly driving this relentless coastal deformation, and what dangers are still undiscovered just beneath our sight? As the USGS lifts the veil on our most vulnerable fault lines and the powerful forces reshaping our shores, are we prepared for what lies ahead, or are we on the verge of confronting hazards we have yet to fully understand? Earth's shifting skeleton, the underlying mechanics of coastal deformation. Comprehend the scale of what's unfolding along America's coasts, we must start at the foundation. Beneath serene horizons and bustling ports, the continent's very bones, its tectonic plates, are in perpetual motion. This geologic ballet is not new, but recent findings show it's increasing in complexity and threat. The western United States is unlike most parts of the world. Here, the crust is deceptively thin, a fragile shell overlaying enormous tectonic energy. This thinness isn't mere trivia. It's the reason the region experiences such frequent and powerful ground shakes. The birthplace of America's greatest earthquakes lies not just in dramatic headlines, but in the very fragility of this ancient stone canvas, twisted and strained by relentless forces below. At the heart of this quake-prone landscape is the Cascadia Subduction Zone, a significant fault running about 100 miles offshore, stretching from Northern California through Oregon and up to Washington and British Columbia. This zone marks the boundary where the Juan de Fuca Plate is subducted beneath the North American plate. The subduction process here is stealthy, building mechanical tension over centuries until, in an instant, it releases with world-altering violence. But Cascadia is just one piece of a sprawling puzzle. The San Andreas Fault may rival it in fame, but USGS's new mapping shows there are nearly 500 additional, previously under-recognized faults, each capable of producing damaging quakes. Some of these hidden fractures run close to major cities, their very existence difficult to imagine only a generation ago. Scientists now face a sobering realization. The apparent tranquility of coastal life is only an illusion. The forces arrayed beneath the surface have the potential to permanently alter not only the ground we walk on, but also the very boundaries between land and sea. How do these deep, unseen movements lead to the slow-motion warping, deformation of entire coastlines? Is it possible that the Earth is quietly setting the stage for calamity, one imperceptible shift at a time. Mapping the invisible, USGS technology, and the hunt for danger zones. For decades, the task of mapping faults was painstaking and often uncertain. Relying on incomplete records and sparse seismic readings, scientists could only peer dimly into the labyrinth below. That's no longer the case. Today, an unprecedented armada of satellites, drones, seismographs, and specialized imaging tools is making the invisible visible for the first time. At the heart of this revolution is the USGS's latest map, a stunning achievement and a sobering one. With new tools and technology, researchers have identified nearly 500 additional faults that lie in wait along the American coastline. But finding these faults isn't just academic. Everyone is capable, under the right circumstances, of producing a quake strong enough to level buildings, crack open highways, and disrupt the lives of millions. And as these newly mapped danger zones come into focus, it's clear that some run perilously close to places considered immune in the past, a chilling reminder that disaster could begin literally beneath our feet. The data paints a far more dramatic picture than ever before. Seemingly stable landscapes are, in fact, riddled with interconnected weaknesses. Some faults cut through densely populated areas, others snake silently beneath the sea, poised to strike with little warning. The evolving landscape of risk, as captured by the USGS, reveals just how thin the line is between everyday routine and unimaginable upheaval. One discovery particularly stands out. A new study brought before the world at the Seismological Society of America's annual meeting asked a deceptively simple question with enormous implications. How wide are faults truly? The answer, drawn from state-of-the-art observations, was more unsettling than anticipated. These fractures can be surprisingly broad, sometimes spanning several miles in hidden complexity. This means the impact zone of a single earthquake may be vastly larger than previously thought. But technology's revelations carry a darker message. Our growing ability to map the Earth's internal architecture is not quelling fears, it is raising new ones. Faults once considered too minor for concern are now understood to possess the potential for major devastation. Which of these newly discovered fault lines will prove the most dangerous? Are there still more lurking, unseen, and unmeasured beneath our cities and coastlines? The Cascadia Subduction Zone. Every coastline has its stories of storms, but the Pacific Northwest sits atop a menace profoundly more dangerous and mysterious. The Cascadia Subduction Zone. This vast undersea fault, running parallel to the continent just offshore, is the ultimate source of long-term deformation along the coast. The Cascadia is not just any fault, it is a tectonic titan, where the Juan de Fuca plate slips inexorably beneath North America. The two slabs of the Earth's crust lock together, accumulating enormous pressure over centuries. Eventually, this pressure breaks free in the only way it can, in an earthquake of tremendous force. The U.S. National Seismic Hazard Model now estimates a 15% chance of a magnitude 8.0 or greater earthquake along this zone. To grasp the gravity, consider this. A quake of this size does not merely shake a city, it rescripts the entire region. The last such rupture centuries ago sent forests plunging into the Pacific, dropped coastal land by several feet in seconds, and sent a tsunami racing across the ocean. If Cascadia ruptures again, the devastation could extend from Northern California to British Columbia. Coastlines could shift in an instant. Land that was once above sea level could suddenly be at, or even below, the tide line, inviting catastrophic flooding as seawater rushes in. Cities, towns, and critical infrastructure on low coastal plains could be inundated within minutes. Tsunamis are only part of the story. Ground deformation, subtle in the years before the quake, explosive during the event, can permanently reshape swathes of land. Land can drop, rise, or tilt in mere moments, toppling bridges, wrecking roads, and isolating communities. The most haunting aspect is the unpredictability. The Cascadia Subduction Zone has been mostly silent in living memory. Its last great quake is a matter of legend rather than eyewitness news. Yet geologic records, ghost forests, offshore sand deposits, sunken lands testify that this tranquility is just a pause, not a permanent peace. Beyond Cascadia, fault complexity, and the southern coastline. While the drama of the Cascadia Subduction Zone captures imagination and concern, the southern reach of America's coastline tells its own unsettling tale. Here, new USGS studies reveal that the tectonic mosaic is far more intricate and potentially threatening than previously understood. A recent investigation brings into focus at least 2 major earthquake faults lurking off the coast of Southern California, each with the capacity to produce more than just ground shaking. They are now recognized as capable of spawning damaging tsunamis, waves that can, in moments, transform seaside towns into disaster areas. But why are these faults, identified as critical only recently, so dangerous? The answers lie in both their location and their behavior. Positioned just offshore and near densely populated areas, these faults can produce both seismic shaking and seafloor displacement, the mechanism that triggers powerful tsunamis. The pattern emerging from these maps is concerning. The many smaller faults, each with their own characteristics and histories, may constitute an overall danger greater than any single well-known fault. In the earlier days of seismic research, attention focused on familiar names like the San Andreas. Now, scientists recognize the collection of newly revealed faults, some hidden beneath sediment, others veiled below the ocean, could, under certain conditions, experience multi-fault ruptures. This means a single earthquake event could jump from one fault to another, amplifying destruction. And the threat doesn't just linger offshore. After a magnitude 7.0 earthquake in early December shook the region, researchers observed that it affected not only known breakpoints, but also stressed the northern tip of the San Andreas Fault, close to where the rupture of the 1906 San Francisco earthquake ended. Each event and each analysis hints at a system where danger zones are dynamic, not fixed. Beneath sunny beaches and busy marinas, the ground is less solid than it seems. Are we facing earthquake risks that, until recently, were invisible on our maps? What might happen if several faults unleash their energy together? Sinking shores, subsidence, floodplains, and the threat from above. Not all coastal deformation reveals itself through sudden, violent earthquakes. Sometimes, the danger creeps in slowly, with consequences just as profound. The USGS and collaborating researchers have identified a quieter but equally insidious threat: subsidence. Across the U.S. East Coast, the ground is sinking, sometimes at rates up to 5 millimeters per year. It might not sound like much, but in combination with sea level rise, and over decades, this downward shift adds up, transforming inches and feet of lost elevation within a lifetime. This process, known as glacial isostatic adjustment, GIA, is the lingering legacy of the last great ice age. Millennia ago, glaciers weighing trillions of tons pressed down on the land's crust. Now, as the glaciers have receded, the land is slowly rebounding in some places, while in others, especially along the coast, it is sinking instead. But it's not just ancient forces at work. Human activities, such as groundwater pumping, oil extraction, and the expansion of urban infrastructure, can accelerate subsidence by causing the underlying soil to compact. The USGS warns that, by 2100, coastal floodplains will have expanded significantly. Areas once considered safely high and dry may become flood-prone, even during minor storms or moderate events. Where subsidence meets rising seas, the risk intensifies. A storm surge or tsunami triggered by a distant event could suddenly turn suburbs and ports, entire neighborhoods, into extensions of the sea. Emergency managers are left grappling with a new reality. Flood maps from a decade ago are increasingly outdated and may fail to capture the shifting risks posed by a sinking coastal landscape. It's a slow-moving threat, but one that could quickly lead to ruinous flooding during storms or following seismic events. How many communities along the coast, unaware of their gradual descent, are living with an invisible and cumulative risk? Hidden faults, hidden peril, the challenge of fault width and multi-hazard zones. Just when scientists thought they had cataloged the dangers hiding beneath the coast, new research unveiled another source of concern: the true width and structure of fault zones. Until recently, many faults were seen as relatively narrow, a distinct crack in the rock. But breakthroughs in observation and analysis, revealed at recent scientific conferences, demonstrate that some faults can span surprisingly wide bands, stretching miles in hidden complexity. Why does this matter? For one, the area that could be affected by a rupture is much larger than once believed. That means a powerful quake could generate ground shaking over a broader region, placing more communities at risk. Even more concerning, wide fault zones often overlap with other hazards. Nearly 500 newly mapped faults intersect with areas already vulnerable to subsidence, tsunamis, and coastal flooding. Where these dangers converge, risks multiply. A single event, a quake, a storm, or a tsunami, could unleash compounding disasters, collapsing infrastructure, triggering slides, and amplifying the spread of water. In this new era, the old thinking, one fault, one hazard, no longer suffices. Emergency planners and engineers must prepare for a future where multiple hazards overlap and interact when the ground moves. Potential damage has never been more widespread. Along the coast, the ground is shifting in ways that were invisible just a decade ago. Undiscovered risks may still be lying in wait, ready to reveal themselves with the right combination of natural forces. A growing risk by 2100. What the future holds for coastal communities. The USGS's latest projections paint a future no one can afford to ignore. Coastal deformation is not just an academic concern. It's central to the fate of millions living near the sea. With each passing decade, the boundaries between land and water are rewritten. Subsidence, seismicity, tsunami threats, and the growing tally of newly detected faults all combine into an evolving landscape of risk. As models now show, coastal floodplains will expand throughout the 21st century, changing the face of many American shores. By 2100, entire areas now home to communities and infrastructure could transition into wetlands or open sea, challenging our understanding of what is permanent. Every beachfront property, every highway, every industrial port faces a revised and uncertain future. Already, decision makers are weighing hard choices. Should we rebuild higher and stronger, or retreat from the most vulnerable areas? Should we invest in ambitious new sea defenses, or plan to relocate infrastructure? The catalog of faults, each mapped in ever greater detail, requires a new level of preparation and adaptability. Realtors, homeowners, city planners, insurers, they all now keep one eye on the evolving USGS maps, searching for clues about the future of the land beneath their feet. The conversation is no longer if, but when and how severe the next seismic or flooding event will be. Even with advanced tools and relentless research, mysteries remain. Are we underestimating the impact of accumulated small tremors or the combined effects of unrelated forces, say, living with the unknown beneath our feet? For all that science has revealed, much about coastal deformation and fault danger remains shrouded in uncertainty. The USGS's new maps, impressive as they are, remain a snapshot, an estimate built atop centuries of incomplete records and changing understanding. How certain can we ever be when the width and complexity of fault zones remain under study and newly discovered faults number in the hundreds? Their possible interactions are often only dimly understood. Even probabilistic models, like the 15% chance of a large earthquake, cannot fully predict when or where disaster may strike. The statistics can seem impersonal, but they are measured against actual lives, homes, and communities. The land's slow sinking is driven by both the planet's ancient past and modern human intervention, shaped by glaciers that have long vanished and by every well we dig or building we construct. In this landscape, certainty is fleeting, and the line between normalcy and disaster is thin. Perhaps the most significant truth now before us is that knowledge brings no sure outcomes, only an opportunity to prepare, adapt, and rethink our sense of safety. As the USGS continues to refine its maps and models, each discovery is a step forward, but also a reminder that we inhabit a changing, dynamic Earth. So, we turn the question to you. Having glimpsed these powerful forces, both sudden and slow, that are reshaping the American coast, do you think our communities are ready for the next great test? Will ever-improving science keep pace with the changes beneath our feet? Or are we forever trying to catch up with the planet's restless motion? Share your thoughts, your concerns, and your ideas in the comments below. If this exploration into the hidden world beneath our beloved beaches and shorelines has brought new perspectives, don't forget to subscribe for more deep dives into the forces that shape our world. Thank you for watching. Stay safe and keep questioning the ground beneath your feet.